Suppose we want to write a JavaScript program that keeps track of a variable called counter and increments that variable by 1 each time we call some function named add. How might we go about implementing such a JavaScript program? Well, one possibility is to implement it like this. In this implementation, we've created a counter variable in our global scope and then defined a function called add where we increment that counter variable by 1 each time. To verify that it works properly, we've invoked that function add twice and then logged our counter variable to the console. Let's go to the browser to make sure that this does what we think it will. And indeed it does. After calling the add function twice, it properly prints to the console the counter variable, which now contains a value of 2. But there's a big problem with this approach, and that problem is that the counter variable is in the global scope, meaning that it can be accessed and mutated by anywhere in our program. And we don't want that. Our design specifies that we only want the add function to be capable of changing this variable. So how might we fix this program such that the counter variable is only accessible inside of the scope of the add function? Well, we might be tempted to think, oh, that's easy. We can just change it so that we declare the counter variable inside of the add function. Now it's contained within that scope. And note that we've also had to change the function to return the counter variable since it's no longer accessible in the global scope. And we've also changed our console log statement to call the function add, because if we tried to access the counter variable outside of the add function, we would get an error. So in this example, we're calling the add function twice and logging it both times to the console. What do we expect it's going to log to the console? And in both cases, it logs the number 1 to the console. That's because each time we call add, the counter variable is being redeclared and reinitialized to 0. So it only ever gets incremented once before being destroyed and redeclared again. Okay, here's the million-dollar question. How do we implement a program that keeps track of a variable called counter and increments that counter by 1 each time we call some function add without redeclaring that counter variable each time, but keeps it encapsulated within the scope of the add function? Well, as you might expect by the name of this section, the answer is to use something called a closure. A closure is this bit right here. It's this return function inside of some parent function. In this case, our closure is contained inside a self-calling anonymous function. The parent anonymous function gets called once when our program loads, and then after that, the add variable will return that closure that we specify within that anonymous function. And what's really cool about closures, what's really cool about that function that we're returning that increments our counter by 1, is that it maintains access to its parent scope even after its parent scope has returned. So that parent anonymous function that gets self-called returns at the beginning of our program, but our closure, that return function that's now assigned to that add variable, maintains access to the counter variable, even though its parent function has already been called. So it's a little bit weird to think about, but a very important concept in JavaScript to understand closures and understand that closures allow us to maintain access to a parent scope even after that parent scope has returned. Let's go to the browser to see how this works. And we see that we've properly logged 1 and then 2 to the console. And the process of how this happened is that first the anonymous function gets called, and then after that, when we call add, it returns that closure function that has a counter set to 0 and then increments that counter by 1. Then when we call the add function again, it has a counter that's set to 1, remember, because it maintains access to its parent scope, then adds another 1 to that counter variable and returns it. It's pretty cool stuff, and I would encourage you to play around with it a little bit more to become more familiar. And once you feel fairly comfortable, let's move on to the next section.